Math 252 section 7.1 video 3. We're going to talk more about the Laplace transform, and this video, or right now, we're going to tell you that it's linear. This is actually pretty much example 5 in the book. The Laplace transform is linear, which is to say that it preserves linear combinations. So the Laplace transform of alpha times f plus beta times g of t is alpha times the Laplace transform of f plus beta times the Laplace transform of g. And we can prove that pretty easily, because let's just use the definition. By definition, Laplace transform of alpha f plus beta g is equal to the integral from 0 to infinity e to the minus st times alpha f of t plus beta g of t dt, and then we can distribute the e to the minus s of t and then use the linearity of integration. So that's alpha times the integral e to the minus s of t f of t dt plus beta times the integral from 0 to infinity e to the minus s of t s times t g of t dt, which is by definition alpha L of f of t plus beta L of g of t. So Laplace transform is linear. Therefore, if we took some linear combination of the ones we've already found, we can just use linearity to solve it. For instance, example, how about the Laplace transform of, let's say, what are the ones we did? 1, let's say, plus, let's say, 3 e to the minus 3t plus, let's say, 2 sine of 2t. Well, that's just going to be the Laplace transform of 1 plus 3 times the Laplace transform of e to the minus 3t plus 2 times L of sine of 2t by linearity. And we found that L of 1 is 1 over s. And L of e to the minus 3t was 1 over s plus 3. So that's plus 3 over s plus 3, and 2, and the Laplace transform for sine of 2t was 2 over s squared plus 4. And for the first one and last one, s has to be greater than 0. For the second one, s has to be greater than -3. For all of these to make sense, s has to be greater than 0. All right, let's list out. Book calls this theorem 7.1.1. And this is the transforms, the Laplace transforms of some basic functions. First one we saw, Laplace transform of 1 is 1 over s. This is all in your book. Laplace transform of t to the n is n factorial over s to the n plus 1 power. And that's for any positive integer value of n. C, Laplace transform of e to the at is 1 over x minus a. That's an a there. D, Laplace transform sine of kt is equal to k over s squared plus k squared. E, Laplace transform of cosine of kt is equal to s over s squared plus k squared. F, Laplace transform of hyperbolic sine is equal to k over s squared minus k squared, and G, the Laplace transform of hyperbolic cosine is s over s squared plus k squared. Let's shrink this down a little bit and put a nice box around it because we can. Yeah, there we go. And this video is long enough. So in the next video, I might talk a little bit about, we saw everything we need to see in the examples that you should be able to apply to figure out all of these functions in the generality that we have them. Remember, hyperbolic sine and hyperbolic cosine, you can just use the definition in terms of e to the x, and then use the linearity to derive these two formulas, the last two.